Let's start with the warm-up. Can you write an equation to represent the following situation? You invest $1,000 in an account that gives you 3% a year. All right, this is exponential, and with exponential functions, we always start with the starting value, y equals 1,000. And it gives you 3% per year, so you're gaining 1 plus 3% a year. Change the 3% to a decimal. And then x will be how many years you get that interest for. So here it is, y equals 1,000 times 1 plus 0.03 to the x. The 1 takes the $1,000 from the time before and adds 3% to it. Class, we watch a cell division video, which says that in human cells, we start, or a human starts as one cell, and it divides in half each time it divides, and so there's the x. Here's the equation. Another way that you could write that is y equals 2 to the x. So sometimes the starting value they don't write if it's 1. And the way that you know it's the starting value or not is the starting value does not have an exponent, but the rate at which your function increases or decreases does. So here the base 2 has an exponent, and so we know that that's that rate of change piece instead of the starting value. All right, let's take a look at that function, y equals 2 to the x. It is a function. It passes the vertical line test. And the shifting rules follow the same idea as last chapter. So if we take a look at this function in black, y equals 2 to the x, and it shifts right 2 every time, we can write the equation of the shift as y equals 2 to the x minus 2. Okay, they have x minus 1, that's wrong. So it should be shifted right 2. This one, the slope is 1/2, or the starting value, and so you can see it's less steep. They multiply each of the coordinates by 1/2. So that's on your assignment, the shifting of the functions, and the ones in your assignment are just up, down, left, and right. They don't deal with slope. Okay, let's look at the equation. The second equation that we look at for exponential functions is y equals our starting value, 1 plus or minus, here it's going to go down, depreciates by a certain rate to the x power. So in this problem, let's say you buy a car for $14,000, and the value of the car depreciates or goes down by 1/5 of its value every year. So if it's depreciating by 1/5, first of all, let's change 1/5 to a decimal. 1 divided by 5. If you type that in your calculator as 1 divided by 5, it's 0.2 or 20%. If your car is losing 20% of its value, then it's still worth 80%. So to show that in the equation, we have y equals 14,000, 1 minus 0.2, so you have 100% minus 2%, or 20%, not 2%, 20%, and that's 80%. So here's the equation we're going to use. 14,000 the first year, and every year it's worth 80% of the year before it. So there's the equation. And for 2 years, you're going to type in a 2 for time. So 14,000 times 0.8 to the power of 2. And that ends up being, I think, 8,960. Let's double check. Yep. 14. So after 2 years, you can only sell your car for $8,960. The second question, when is the car worth half of its value? So now we know the y value in the equation. The y value is 7,000. And that equals 14,000 times 0.8 to the x. All right, let's solve for x here. First step, use opposite order of operations to get rid of that 14,000 by dividing. 7,000 divided by 14,000 is 0.5. So now we get 0.5 equals 0.8 to the x. We run into a little problem. We don't know how to solve for x if it's an exponent. So we're going to use guess and check. We can use an educated guess and check because we know that after 2 years the car's worth 8,000. So we know it's more than 2 years for the car to be less than that, 7,000. So we're going to use guess and check. We'll just pick a number. So let's try 0.8. Let me pull up my calculator. Whoops. 0.8 to the 3 and see how close do you get to 0.5. So if I type that in my calculator, 0.8 to the power of 3, 0.8 to the power of 3 equals 0.512. That's pretty close. Let's see if we can go closer. So let's try 0.8 to the power of 4, see what happens. And it becomes way less, 0.4096. So we know it's between 3 and 4 because we want to get it down to like 0.50. So let's try 0.8 to the power of 3.1. And that is really close. It's 0.500702. So we're going to say x is 3.1 years. So guess and check is the only method we have when we're solving for x as an exponent right now. And further on in the chapter, we're going to learn other methods that you could use to solve for x if it's an exponent. Oops. All right. I think my calculator's up now. Okay, let's try the next problem. Open a calculator here. Okay, so in this next problem, Malika invested some of her summer earnings into an account. She put her earnings in a table that looked like this. So this is some kind of savings account. She's earning interest. Define variables and write an exponential equation for the situation. So starting value would be 200. We need a rate of change. We know it's increasing, so this number should be bigger than 1. To figure out a rate of change from a table, you can take any term and divide by the number before. Because remember, to find any term, you're multiplying by a certain number, so we're going to work backwards. We're going to take any number, divide by the one before it. So let's try 212 divided by 200. And that's 1.06. And that makes sense. It's increasing, so there's the one. It's increasing at 6% per year. This pattern continues. How much will she have in 6 years? So you just type into your calculator. So when I give you time, it's really easy. Once you have the equation, you just plug in and get an answer. So we have 200, 1.06 to the power of, and how many years was it? 6? All right, so now in her account, she has $283.70. So again, if you can set up the equation, the starting value and the rate of change, if I give you time, you just plug in and get an answer. Well, the next question, how many years will it take her to have 500 in the account? So now they're giving us the y value. 500 is the money in the account. That equals 200 times 1.06 to the x. All right, let's solve. Let's get rid of the 200 first. We get 2.5 equals 1.06 to the x. Again, we run into that problem where we don't know how to solve for x if it's an exponent, so we're going to use guess and check. Educated guess and check. We know that in 6 years she has 283, and we want 500, so it's more than 6 years. So let's guess, I don't know, 10. 1.06 to the 10th power, and see how close we get to 2.5. All right, 1.79 is still too low. Let's try 15 years. Again, we're looking for 2.5. 2.39, let's go higher. Let's go 16 years. All right, we're close. We know it's between 15 and 16. And so in class we work this out, and I think students actually get the closest to be 15.75 years, and that's the closest to 2.5. We could go even closer, but that's about how far we get. So x is about 15.75 years, and she'll have 500 in the account if everything remains the same. So your assignment, you'll have a few different problems. One where you have to find the shift of the graph, some where you have to write the equation and plug in and solve, or find the equation, use guess and check to solve.